All right, Algebra 1, here we go again, guys. We are looking at section 5 today, and little cheers to you, afternoon coffee for Mr. A. We are looking at parallel and perpendicular lines. All right, this is a good one. We are not getting away from that slope-intercept form that you see right there. Okay, so we are still working with slope-intercept, but we are messing around with the actual slope part of that equation. Okay, everything that we're doing in this section when it comes to parallel or perpendicular lines, our first step is always going to be make sure that we are in slope-intercept form. Okay, first step. If we're not in slope-intercept form with y being totally by itself and isolated, then this is not going to work. Okay, so step one, slope-intercept form, making that very clear. If you are in slope-intercept form, then you can then go and look at the slope, because that is the most important part of this equation when we're looking at, hey, are these lines parallel or are these lines perpendicular? Okay, notice we're talking plural lines here because we're going to be dealing with two equations. All right, and once we know these two equations are in slope-intercept form, then we can move on to this part right here, looking at parallel lines or looking at perpendicular lines. And again, you'll notice I've highlighted just that really important part. If parallel lines are being shown, then you will notice that we have the same slope. It does not matter about the b value. Again, it does not matter about the y-intercept. What does matter is if the slopes of each equation are the same, then we are looking at parallel lines. If the slopes are different, then we want to see how are they different. Okay, how are they different? Because if they are opposite reciprocal, then we're in a perpendicular line situation. Okay, and let's look a little bit further down the page just at some real basic examples of what I'm talking about here. If lines are parallel, then you're going to notice that the slopes are the same. So for those equations, y equals 3x plus 4, y equals 3x minus 2, it's clear. There's the 3x, there's the 3x, parallel situation. Okay. However, what does it mean for something to be an opposite reciprocal? Okay, let's look over here at the perpendicular part. And if you can see, let's say the slope we're talking about here is 4. What's the opposite of 4? The opposite of 4 is negative 4. Then what's the reciprocal of that? Negative 1/4. That's what I mean by opposite reciprocal. Okay, so that means if we start with a negative, what's the opposite? A positive. And then reciprocal, flip the number. Okay, that means if we start out with this whole number 4, we have to understand that there's a 1 in the denominator. It's never written. So the reciprocal of this would be flipping it and then making it 1/4, and then the opposite right there. So that's what I mean when I say opposite, then reciprocal. And if that's the case, then we're in the world of perpendicular here. Okay. All right, let's move down the page. And again, both equations, slope-intercept form. I think I made it really clear up above, but again, it must be both equations. Then you are looking at the slopes to determine if we're talking parallel or perpendicular. Okay, let's do some example problems. You'll see what we're talking about here. All right, so first one, write the equation of the line that goes through the given point being 5, -1, and is parallel. Important. I've highlighted that word parallel because we want to make sure we know parallel means same slope. So the slope that we are given is -3/5. We don't care about the y-intercept value. We care about the slope. So I see an x here, I see a y here, and I see my slope here. So let's plug in the values that we have, because now we need to get a brand new b value, which essentially is going to be giving us a whole new equation, except for the fact that we're going to have the same slope. So -1 equals -3 over 5 times 5. By the way, I'm going to put that over 1 because we're multiplying fractions. It's easy to go straight across. Then we're going to say plus b. All right. And then this works out quite well because the 5s will cross each other out, leaving you with a -3 over 1. So this is now looking like -1 equals -3 plus b. And then we will add 3 to both sides, and that's going to give us b equals 2. All right, now we have the b value for the new equation. We know the slope is the same because they asked for the parallel equation. So now let's go ahead and write the equation y equals -3/5 x plus 2. That is now the brand new equation that will have the same slope. We know it's parallel then, but it will go through the given point 5, -1, because those were the values we used for x and y. Okay, so those are the steps you're going to take. Focus on the slope. If they say parallel, keep the slope the way it is. Look at the point they give you, pull out the x, pull out the y, solve for a brand new b, and then at the end, put it all back together to create the new equation. All right, let's do another example problem, but this one is perpendicular. Okay, so now what we're looking at is here's our x, here's our y, here is our m, but perpendicular, meaning it is the opposite reciprocal. So if we are starting with 3, the opposite is -3, and the reciprocal would be a -1/3. So that right there is actually going to be my slope for the perpendicular line, opposite reciprocal. We have x is -9 and y is +2. Now we can plug in some values. All right, so here we go. 2 equals -1/3 multiplied by a -9 over 1 plus b. All right, now let's do some cross reducing. Kind of works out nice that way. This will reduce to a 1. The -9 will actually reduce then to a 3. So we are looking at a -1 times a -3. -1 times -3, actually now just giving us regular 3. So 2 equals 3 plus b. And then we need to subtract both sides by 3. b equals -1. Now put it all back together. All right, don't forget, this is our slope. This is our brand new b value. So now we have y equals -1/3 x minus 1. There's our new equation that will be perpendicular to the given equation, and it will go through the point -9, 2. All right, let's move in. Last 2 example problems that we have here. So determine which lines are parallel or perpendicular. So we're given the equations already. All right, so nice enough, both problems, 3 and 4, the equations are already set up in slope-intercept. Perfect. We don't really need to move anything around. We just need to focus on the slope. And I see a -1/4. I see a +4. These guys would be opposite reciprocals of one another, meaning that these equations right here, these would be perpendicular. Okay, now let's look at number 4. I see 2/3. I see other one is identical. It's 2/3. So these ones right here are parallel. Okay, that's simply a matter of make sure it's in slope intercept. If it's not, put it in slope intercept. Look at the slopes. Doesn't matter what that y-intercept is. Is it opposite reciprocal? Perpendicular. Is it identical? Parallel. All right, guys, that's all I got for you. That covers everything in section 5 for parallel and perpendicular lines. All right, we will see you in the next one.